reaction of acid with metals.
Okay. We have acids, bases, and salts. So generally, when we start with the tasting of the different substances, so this chapter starts from the nature of substances. So we have seen the substances. Here we are dealing with their nature. What is the nature of the substance? Okay. So the nature of the substance can be either acidic, or it can be basic, or it can be neutral, which can be salts. So acids, bases, or salts. Now, what are acids? Can anyone say what are acids? How do we define acids?
Acids are like substances that produce hydrogen ions, right?
Yeah.
In their aqueous solution.
So acids are the substances which produce hydrogen ions in their aqueous solution. Okay. Good evening, Kashvi.
Yes, sir.
Good evening.
Good evening, sir.
Okay. So during the class, if you are feeling to speak anything, maybe your doubt, maybe suppose if you want to ask anything, you want to add anything to the answers or whatever discussions, you are free to participate at any time. All right. If you are not getting anything, so you can interrupt any time during the class. Okay, there may be some of the concepts like which you may know. So just add something if you can add it. And during the class, it is advisable to all of you to keep your cameras on. All your cameras should be on during the classes. However, you can eat some snacks, you can drink along with your studies. This is for everyone. Okay. So you can do, you are free, but do not leave the class. When you are in the class, do not leave the class without informing. Okay. If you have some emergencies, you can inform, you can leave. Dhriti, Pranaya, everyone turn on your camera. Okay. So see, I got a very good definition that acids are the substances they are the substances that give H plus ions. H plus ions or hydrogen ions in their aqueous solution. Okay. But this is not the only definition of the acids. Different scientists, different chemists studied acids and they give different definitions. Okay. So you have regarding the acids, you have Bronsted and Lowry concept of the acids. These are the different concepts. You have Bronsted and Lowry concept, Arrhenius concept, Lewis concept. So different chemists define acids in different words. This very definition that the substances that give H plus ions in their aqueous solutions will be called acids. This is the definition of Arrhenius concept of the acids. Okay. A similar definition was given by Bronsted and Lowry also. Lewis, he expanded the definition into more depth that even the substances, there are substances which do not give H plus ions, but they also show acidic behavior. Okay. So you don't have to go into the much depth, but yes, there are different concepts of the acids. Different people understand acids in different ways. In common terms, commonly what we can say, the substances which are sour to taste. This is common thing. substances that are sought to taste. They are acids. Okay. The obtained from the word acidus. So acidus means sour. So that is where we come to the acids. Now, first we recognize the things around us which were sour in taste. For example, we recognize the tamarind, lemon juice, tomato, unripe mangoes. So are all these substances sour to taste? Yes. All these substances are sour to taste. Therefore, they must contain some acids in them. And those acids which are found in these substances, they are the organic acids. So these acids which are present in them, they are present naturally. They are made naturally in the living organism. So the acids which are extracted from the living organisms, they are the organic acids obtained from the word organism. Okay, organism, organic. So those acids which are obtained from living organisms, they are organic acids. So tamarind, it contains tartaric acid, lemon juice, citric acid, tomato contains oxalic acid, unripe mangoes, they contain malic acid. Okay. Which acid is found in oranges? Yes,
Citric.
which acid is, which one?
Citric,
Yes,
sir.
citric. Yeah, oranges and lemon juice, both of them, they contain citric acid. And that is why they are called citrus fruits. And can anyone tell me any other name for citric acid? Any other name for citric acid? Yes, can you tell me any other name for citric acid?
No idea, sir.
No idea. Okay, what about vitamin C? Vitamin C is another name for the citric acid. It's the same thing. Okay. It is a water soluble, so it can easily dissolve in water. Okay. So citric acid is also called vitamin C. Now all these are organic acids as they are obtained from the living organisms. They can be consumed. They are consumable. We can eat them. All these acids, we can eat them. Okay. So these acids, they are consumable. Got it?
Sir, I got disconnected in between. So what were you discussing before the organic acids?
Uh, so up to now we have discussed here the organic acid contained by different substances. Acids means the substances which are sought to taste. Okay. So naturally occurring means we are obtaining the acids which are obtained from the living from organisms, which are obtained in the organism's body. For example, the tamarind, which is of tamarind itself contains the tartaric acid. Lemon juice contains citric acid. Tomato contains oxalic acid. Unripe mangoes, they contain malic acid. And lemon juice and oranges, both of them, they contain citric acid, which we also call as vitamin C. So vitamin C is another name for the citric acid. Got it? So all such acids, they can be consumed, but there are certain acids which cannot be consumed. They are also found naturally. They can also be made in the laboratory. Okay. So some of them they can be found naturally also, but generally not found in the living organisms. They do not manufacture. Okay. So those acids, they are your mineral acids. They are obtained from the as a mineral. So mineral acids. mineral acids. Mineral acids, they include hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, carbonic acid, H2CO3. Okay. So remember, carbonic acid is a mineral acid. It's not an organic acid. Okay. So carbonic acid, H2CO3, sulfurous acid, HSO4, H2SO3. These are different mineral acids which are found around us. You have a number of them. A number of mineral acids are available. A number of organic acids are also available. Okay. So we have understood that acids will be the substances which are thought to taste, but it's not easy to, and it's not also beneficial to consume, taste all the acids, to taste every substance and check whether it's sour or not. It can be harmful for us. It can harm us in a number of ways. So we call them. So we have different mineral acids. They are hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, sulfurous acid. So we will see some differences between them. Which of them can be consumed? Which of them can be consumed? Yes, organic acid or mineral acid. Which are consumable?
Organic.
Yeah, organic acids are consumable. Now, a common characteristics that all the acids bear is that if you dissolve any acid in water, so if you dissolve the acid in water, the acid in water will give you hydrogen ions. How does it give? The process is very important. Acid in water will give hydrogen ions. All of you know that acid in water will give H plus ions. Plus something else will also be there. Now, if it gives us H plus ions, so we call it acid. This is what we have learned. That if a substance gives H plus ions, we call that to be acid. So the conditions which are there. First of all, acids will give H plus ions only when they are dissolved in water. If they are dissolved in water, then only they give H plus ions. And if they are not dissolved, then they will not produce H plus ions. As suppose I am taking HCl, I take hydrochloric acid. So we know that hydrogen and chlorine, they are bonded to each other with the strong electrostatic forces. Chlorine is highly electronegative in nature, so it attracts the electron pair of the hydrogen. And hence, there is a strong electrostatic force of attraction between hydrogen and chlorine, which bonds them together. So the bonding of hydrogen and chlorine is very strong. So even if you have a dry HCl, it will not behave as an acid. It will not produce H plus ions. If you add water to the acid, so then only you will have H plus ions. So how it happens, let us see. Also one more thing, for a quick revision, I will add. All of you know that water is a bad conductor or poor conductor of electricity. Yes or no? Water is a poor conductor or good conductor of electricity?
So distilled water is poor.
Distilled water or pure water is a poor conductor of electricity. So if you have distilled water is a poor conductor of electricity. Again, I say this is very important. Distilled water, it is a poor conductor of electricity. Okay. Why the distilled water is poor conductor of electricity? Can anyone explain? Aryan, why distilled water is Yes, Aryan?
Sir, it does not have that minerals which conduct electricity, no, sir.
Can anyone else? Abhinav, can you tell?
No hydrogen atoms.
No ions. There are no ions present. H2O or direct, if you have distilled water, so distilled water is just H2O. It does not have any ions in it to conduct electricity. As you know, there should be presence of some charge carriers for conduction of electricity. Like in metals, you have free electrons, which are the charge carriers for the conduction of electricity. Right? If you have distilled water, so in distilled water, there are no charge carriers. There is no hydrogen ion. There is no none of the ions are present. So distilled water is a poor conductor of electricity. So a pure HCl, if you have dry HCl, so dry HCl, this is also a poor conductor of electricity. If you have distilled water, so distilled water is also a poor conductor of electricity. Both of them, they have the same region. Okay. Why HCl is a poor conductor of electricity? Can anyone explain? Why dry HCl is a poor conductor of electricity?
Because it does not have ions.
Yeah, because it doesn't have ions. So now see what will happen when we dissolve an acid in water. So suppose I dissolve the acid HCl in water. Now there are some intermolecular forces which start playing, and they break up the bond between hydrogen and chlorine. They also break up the bond in water also. So both the bonds are broken. Now how do they break? So HCl breaks down to give H plus and Cl minus. See, understand this concept very clearly. This concept is very important for all of you. Very, very important. So HCl dissociate to give H plus ion and Cl minus ion. Right? Now what will water dissociate? This, understand this H2O, it first dissociate to give you H plus ion and OH minus ion. Right? It gives H plus ion and OH minus ions, but the H plus ions which are present in water, these H plus ions, they are not stable. Okay, they have a very short life. They are not stable. They can't exist like that. Okay, so they are not stable and they search for their stability. So how do they search for their stability? See, so if you have here, let's try to balance out the reaction. So the reaction is almost, it seems balanced. If I have here 2H2O, so you'll get here 2H plus and 2OH minus. Am I correct?
Yes.
Yes. So this 2OH minus which I obtained here, now this 2OH minus plays a role. So this 2OH minus, it again dissociate to give me H2O, a water molecule, and O negative ion. Okay. So here I have the formation of an oxide ion. And here I have the formation of the hydrogen ion. But still the stability of hydrogen is not established. The hydrogen ion which was formed, it's not established. So this hydrogen ion, it forms a bond with this water molecule. The hydrogen ion, it forms a bond with the water molecule. It comes in association with it and it forms hydronium ion which we call H3O plus. So in solution, you will not be finding H plus ions. You won't get H plus ion. You will be getting hydronium ions. Okay. So here you will get the hydronium ions. Got it? Okay. So for a small interval or for a short time, let us forget this. Let us forget this. I think it will create a confusion here. Now I think you can understand that the H plus ion which has been formed from water molecule, it connects with a water molecule to form hydronium ion which will be available in the solution. So this is more stable. A hydronium ion is more stable Got it? A hydronium ion is more stable as compared with the hydrogen ion. Now, why it's an acid? See, why we call an acid? Do we have here a hydroxide ion in the solution? Yes, Abhinav, do we have a hydroxide ion in the solution?
No, sir.
Again, see the equation clearly. See these two equations. Is there any hydroxide ion in the solution?
Yes, sir.
Yes. Yes, Kashvi, did you observe?
Yes, sir.
Okay. So we have here presence of the hydroxide ion both in this, and we also have the presence of hydrogen ion. Do we have the presence of hydrogen ion also?
Yes, sir.
Yes. So we have the presence of hydrogen ion also. We have the presence of hydroxide ions also. So which one do you think will be more? Hydrogen ions or the hydroxide ions? Which one will be more? Hydrogen ions or hydroxide ions? See, hydrogen ions we are getting from water also, from HCl also. Hydroxide ions we are getting only from water. So whose concentration is likely to be higher?
Hydrogen.
Yeah, here
Hydrogen.
we have the concentration of hydrogen ions to be higher, and we have the concentration of hydroxide ions lower. So that is why now this solution will be acidic in nature. Got it? So you may find questions stating that do the solutions of acids contain hydroxide ions? So what will you say? Yes or no?
So can you repeat?
Do the solutions of acids contain hydroxide ions?
Yes, sir.
Yes. So the solutions of acid contain hydroxide ions. This is a very important concept from assertion and region point also. You should be very much clear to all the points. Okay. So in the same way, here we observe that hydrogen ions are present and the concentration of the hydrogen ions is more. And it depends on how much of the HCl dissociate. So it may happen, suppose if you have 10 molecules of HCl here, and out of the 10 molecules, only 8 molecules are dissociating to form H plus and Cl minus. 2 molecules are still there which do not dissociate. It can happen. Okay. We'll come to this again as a strength of an acid. When we will discuss about the strength of the acid, then we'll come to these points. Okay. Now, in the same way, if you have any base, suppose I have a base NaOH. Okay. All of us know that sodium hydroxide is a base. Yes. Sodium hydroxide is a base or acid?
Base.
Base.
It's a base. So why it's a base? Yes. As it will give us Na plus ion
And OH
and
minus.
OH minus ion, but in water. So why water? If you are taking water here, if you are taking H2O, so if you are adding water to it, you will get here H plus ion and OH minus ion. Now whose concentration is higher?
OH minus.
A hydroxide.
Yeah, now the concentration of hydroxide ions is higher. Okay, so is there a presence of hydrogen ion in the solution?
Yes, sir.
Yes, there is presence of hydrogen ion in the solution of a base. So bases do contain, or the solutions of bases, they do contain the H plus ions. The solutions of acids, they do contain hydroxide ions. The only thing is that the concentration of the ions is less. The concentration of OH minus ion or hydroxide ions in a base will be less. the concentration of H plus ions in acid, the concentration of H plus ions in the bases will be less, and the concentration of hydroxide ions in the acids will be less. Got it? Yes. So understood why do we how can we how we call them as acids? So acids are the substances which give H plus ions in their aqueous solution, and bases are the substances which give hydroxide ions in their aqueous solutions. Okay. Now
sir,
let us see. Yes.
Acids contain the hydroxide ions also, but just the concentration of the hydrogen ions is more.
Yes. Yes. Okay.
Got
So that so from this concept you have some other questions also. Like you have a dry HCl, and if can you test a dry if you test a dry HCl with litmus paper, so will you get a true result? Will there be any change? As acids turn blue, litmus red. So if you test dry HCl gas or dry HCl with the help of a blue litmus paper, so will there be any change?
No, sir.
No. Why? As there are no H plus ions. There are no H plus ions in the solution, so there will not be any change. Okay. There could be a change if there are presence of ions, which will be there only if it is dissolved in water, only if there is presence of water molecules. Okay. Why? Why it doesn't dissociate? Why it doesn't give H plus ion and Cl minus ion when it is dry?
Poor conductor.
Yes. Why? Because of the strong electrostatic forces of attraction between hydrogen and chlorine. Hydrogen and chlorine, they are bonded together with strong electrostatic forces of attraction. Got it? In the similar way, sodium hydroxide, if you have dry sodium hydroxide, it will not show you acidic nature. It will not show you acidic behavior because sodium and hydroxide ions, they are bonded together with strong forces of attraction. Okay. These forces are disrupted when they are dissolved in water. Since water is a polar solvent, okay, water is a polar solvent. Polar solvent means it has some dipole, it has some positive negative charges in it. Water is a polar solvent, so it can dissolve only the polar substances in it. So hydrochloric acid, sodium hydroxide, common salt, all these substances, they are polar molecules. Polar molecules means they have polarity, positive and negative in them. There are certain substances which do not have polarity, like methane gas, CH4, carbon dioxide. Carbon dioxide is also non-polar. So that is why carbon dioxide is soluble to a very less extent in water. It is dissolved only under a high pressure. It has a very less solubility in water. Understood about the concepts of acids and bases here? Yes?
Yes, sir.
Okay. Now let's see about, we had started our discussion with organic acids and mineral acids. Okay. So we had started with organic acids and mineral acids. This is what we have done up to now. Then two other words you also hear. You hear these words dilute and concentrated. These are the two words which you hear, dilute and concentrated. Also you hear about weak acid and a strong acid. Okay. So can I say dilute and weak are the same?
No, sir.
So what is the difference between a dilute acid and a weak acid?
So weak is upon the strength of it, while dilute is upon the quantity of water present in it.
Yes. So dilute and concentrated, it depends on dilute or concentrated. It tells us the amount of water amount of acid or base present in water. Okay. So if you have high amount of water and low amount of acid, if you have low acid and low acid and high water, so then we call it as dilute. However, there is not a perfect line between them. Okay, just low and high. There is not a perfect line between, yes, more than this will be low and more than this will be high. It's not like that. There is not a perfect line, but yes, depending on certain a few rules which can obey, we say that yes, the acid is weak, the acid is dilute, and the acid is concentrated. Both of them, they contain amount of water. Dilute acids also have amount of water content. Concentrated acids also have the amount of water content. In the case of concentrated acids, here in the case of concentrated acids, you have acid content will be more, acid will be high, and water will be low. Water content will be low. So such acids will be called as concentrated acids. And if you have a dilute acid, so in the dilute acid, the amount of acid or base in water will amount of acid will be low and amount of water will be high. Understood dilute and concentrated?
Yes, sir.
Okay. Okay. Then we'll come to weak and strong in the next class. I just want to clarify everything up to dilute and concentrated. Okay. So let us see how we start with the dilution process, how we can dilute acids. Let's see the process
Sir.
of dilution. Yes.
Sir, could you show the previous page, sir? I'm still waiting.
Okay.
Thank you, sir.
Okay. Done.
Yes, sir.
Okay. Let's move ahead now.
Completed, sir.
Okay. So let's see next. The process of dilution. So here we are looking how can we dilute acid. So how can we dilute acids? That means, of course, while you have to dilute, so you have to add water to it. You have to add more and more water, so it will become dilute. Okay. But how do we exactly perform the dilution process? So first of all, to understand this, we get here that the process of dilution, it is an exothermic reaction. Okay. So it's an exothermic reaction. There is release of a lot of, it's an exothermic reaction. So during this process, we find release of release of a lot of energy, a lot of heat energy is released during this process. Just one minute. Hold on for a minute. Okay, so just tell me, am I audible now?
Yes, sir.
Okay.
Yes, sir.
Okay, just because there is some weather problem just now, so I thought of confirming. Okay, so exothermic, it is an exothermic process. So how we can perform this process? Of course, when we add acid to water or water to acid, we will get a lot of heat. A lot of heat will be released during this process. So anyways, continue this discussion in the next class. We stop here at the process of dilution. Anyone having any doubt?
No, sir.
Okay. Okay, so bye and see you all in the next class.
No, sir. Thank you, sir. Bye, sir.